Hey everybody, this is Mr. Ainsworth, and we're going to get into a review on Unit 2 here, which covers sections 5.1, 2, 3, 4, 5, and 6 in your textbook. Okay, this is basically Chapter 5 here in your textbook in Algebra 1. So let's get right into it. Remember, this is a video, so pause, play, rewind, do what you normally do with videos here. Go at your own pace, okay? Keep that in mind. So if I go too fast, pause it, rewind it, and listen to it again, okay? Use your video at your advantage. Okay, so given the linear function or linear relation here, which is a set of ordered pairs, find the linear function. Okay, we're talking about the equation of the line. Equation of the line. All right, using slope-intercept form and point-slope form, basically two different methods. Okay, either method requires you to find the slope first. And as you guys know that the slope, okay, they use M for Monte for the slope, is delta y divided by delta x. So we got to find the change in y first. So the change from -2 to -1, you're just moving right 1 unit on the number line, so it's an increase of 1. Change from -1 to 0 is a change of 1. You're going 1 unit to the right on the number line. The change from 0 to 1 is 1, so delta y is 1. The change in x is 2. It's an increase of 2, right? 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So we can see that delta x is 2. Okay, so what do? Well, we take the delta y, all right, and we divide it by delta x. So I can see that my slope is 1 divided by 2, or 1/2. Okay, the question is what's the y-intercept? Okay, so what you do is we know that the function, whatever it may be, it looks like y equals 1/2 x plus whatever b is. And at this point, I don't know y-intercept because I don't have it in the table. Okay, if I wanted to, I could go backwards, okay, and I can find the y-intercept. I can go back. Well, actually, I do it. That's right here. Ooh, ooh. Okay, so y-intercept 6. No, that's the x-intercept. That's the x-intercept there, not the y-intercept. The y-intercept is when x equals 0. So you'd have to go backwards in the table. Mm-hmm. Backwards in the table. So you can do that if you wanted to, or you can simply pick a point like this right here. I'll tell you what, I'll do two different ways. I'll pick a point, substitute it in to find the y-intercept, and then I'll go backwards using the changes. So if you use the point 6 comma 0, okay, x is 6 and y is 0, and you just substitute it in. So is 0 equal to 1/2 of 6, right, plus something? Well, 1/2 of 6 is 3, so 0 equals 3 plus what? Well, 3 plus what number equals 0? Well, it's -3, right? So, or you can solve for it if you like. So you get -3 equals b. And so my function looks like y equals 1/2 x minus 3. Now, if I went and used the changes, I could get the same value. So if I subtract 2 and go backwards, goes back to 0. If I subtract 1, so it's the backwards of, let me back up here. So going forward, you add 1. Well, going backwards, you subtract 1. So -2 minus 1 is -3. And that, my friends, is the y-intercept, which corresponds to this number right here, the y-intercept. So you can get the y-intercept by using the changes going backwards in your table, or you can just pick a point and substitute it in. Or you can use point-slope form, which requires a point and a slope. Now we already know the slope is 1/2. We already calculated that earlier. And now you pick a point. You can pick 0, 6, 0. You can pick 8, 1. You can pick any point in your table. I'm just going to pick 8, 1 because I'm going to show you that it doesn't matter which point you pick. So you pick a point and substitute it in. Okay, now when you substitute it in, you substitute in for x1, y1. So I have y minus 1, because the y coordinate is 1, is equal to 1/2 times x minus the x coordinate 8. Then when you distribute through, you get y minus 1 is equal to 1/2 x. Distributing it again. Okay, you got to take 1/2 times 8, which is 4, right? So you get minus 4 here. And then you continue and you isolate y, and you get y equals 1/2 x. -4 plus 1, well, that's -3. And notice they're the same. So it doesn't matter what technique you use to solve for the equation, whether you use point-slope form or slope-intercept form, you get the same thing. Okay, given f of x equals -2/3 x plus 2, evaluate the function algebraically and graphically. Okay, so let's graph the function. So we have a slope of -2/3, you have a y-intercept of 2. So that means down 2, right 3. So down 2, right 3, down 2, right 3, and reverse it. Up 2, left 3. And then you draw your line. Okay, and then you're trying to find f of 3, where x equals 3. And you're trying to find the y value. What is that y value? So you got to look on the line. Is there a point on the line where x is equal to 3, where the x coordinate's 3? And, it should be right here. So, x is equal to 3, so look right here. And notice that this point is 3, 0. Sorry about that. Okay, so f of 3 should be equal to 0 because the y coordinate is 0. So I'm going to put a 0 here. Now let's do it algebraically. Let's take the function f of x, which is negative 2/3 times whatever x is, all right, plus 2 more. And let's evaluate the function at 3. So what you want to do is you want to take x and you substitute it in. So you take negative 2/3 times 3 and then add 2. So you can divide first or multiply first. If you multiply first, you got to take negative 2 times 3, which is negative 6, divided by 3, and then add 2, which is negative 2 plus 2, or 0. Or you can divide first, and you still get negative 2. Negative 2 times 1 is still negative 2, and then add 2, you still get 0. So f of 3 is equal to 0. And notice that this is the same. So whether you do it graphically or algebraically, you get the same result. Okay, now we're going to graph an equation in standard form. Ooh, standard form. That's ax plus by equals c. Okay, so method 1 is using intercepts. So if you want to take out, I think it's less than 5. Let me see. Let's see here. So let me go back to 5 real quick. Yes, it is. Okay, so it's lesson 5 where I talk about the intercept method and how to isolate y. So keep that in mind. So I'm going to put that up here at the very top. So see notes. All right, lesson 5-5. Okay. So intercept method. So it's a method of zeros. So put your zeros in, and let's compute. So what is y when x is 0, and what is x when y is 0? You just play with the zeros here. So you put 0 in for x first and solve for y. Okay, that's 0 there, so you get negative y equals 3. Divide by negative 1, you get y equals negative 3, and there's your y-intercept. So 0, negative 3. And then next you substitute 0 in for y. So you get 3x minus 0 equals 3, which will give you 3x equals 3, or x equals 1. And that is called your x-intercept, 1, 0. So if you plot those, 0, negative 3 is here, 1, 0 is right here, and if you graph that from there, it should look like this here. Okay, now the other, let me see, this is x-intercept here, y-intercept here. Now the other way to do it is isolate y. So let's take the equation here, 3x minus y equals 3. Let's subtract 3x first. And you get negative y equals negative 3x plus 3. Divide everything by negative 1. And you simplify the result. So y is equal to 3 now, 3x minus 3. And notice that the slope here, m equals 3, y-intercept of negative 3, or 0, negative 3, kind of matches this right here. From negative 3, you go up 3, right 1, up 3, right 1, up 3, right 1. Okay, use the slope. Remember, the slope of 3 is 3 over 1. That means up 3, right 1. Okay, so this right here, this function here, backs up with what I said over here when you get your x-intercept and y-intercept. Y-intercept here, x-intercept here. All right. That's section 5.5 in your notes, by the way. Okay, now this one here is section graphing functions by plotting points. This is, if I remember correctly, it's lesson 2-3 or 5.3, either 2-3 or 5-3 in your notes. And so what I told you guys, that if you have a fraction involving a linear function, if you want to plot by using points, it would be nice for you, or wise, that you pick an appropriate domain. So when you look at the denominator, which is 4, I would choose multiples of 4. Choose multiples of 4 because it'll make your arithmetic a lot easier. So -4, 0, and 4. Okay, so let's plot, evaluate it. So y is 3/4 times whatever x is. All right, -3. So 3/4 times whatever x is, -3. Okay, so you can take 3 times -4 is -12, divided by 4 is -3. Or you can simply divide here. 3 times -1 is still a -3. Minus 3 more is -6. So -4, -6 is right about here. And then when you put in 0, 3/4 times 0 minus 3 is just -3. So 0, -3 should be here. And then when x is 4, you get 3/4 times 4 minus 3. And let me see, 1 times 3 is 3, minus 3 is 0, so you get 4, 0 should be here. Which kind of makes sense. The slope is 3/4, so you go up 3, right 4. So up 3, right 4. So when you plot points, it backs up everything I say about slope-intercept form. Okay? Okay, so notice that we use the slope right here to verify it. So just pick appropriate domain, substitute it in, evaluate it. Now here I see the denominator 2, so I would choose multiples of 2. So -2, 0, and 2. So here we go, -1/2 times -2 plus 1. So simplify, you get negative times a negative is a positive, 1/2 of 2 is 1, 1 plus 1 is 2. And then you take 1/2 times 0 plus 1, that's obviously 1. And then 1/2 times 2 plus 1 is 1 plus 1 or 2, and then you plot your points. So -2, 2, 0, 1, and 2, whoa, something's wrong here. Oh, I didn't put the negative sign on here. It should be negative. See, look right here. -1/2, -1/2. Here it didn't matter because -1/2 times 0 is 0, and you just get 1. Got lucky there. -1 times 1 is -1, but -1 plus 1, that's 0. So we got to fix this. So -2, 0. I knew I made a mistake because the points were lining up. Remember that. So be smart about it because, everybody's human and we all make mistakes. The important thing is being smart enough to fix them when you make them. Okay? Okay, points must line up. All right. Find the linear function using point sub form. We already did this, so this should be easy. So let's subtract up here. Okay, starting with the y coordinates. So here we go. So slope is equal to 5 minus 4 divided by 2 minus 3. That's 1 divided by -1 or -1. I'm going to pick 3, 4. You got to choose one of these 2 points, so just pick one. Remember this stands for x1, y1. And so when you substitute it in, you put them into their proper locations. So y minus the y coordinate of 4 equals -1 times x minus 3. Distributing through. Be careful on the second distribution, there's a double negative. Add the opposite, and you get y is equal to -x plus 7. Okay, on the next one here, you're going to go from slope-intercept to standard. So this is called slope-intercept. And you want to go to standard form, which is ax plus by equals c. So you want the variables on one side, and you got to clear your fractions. Okay, now to do that, you're going to multiply everything through by 9. So because the denominator is 9. So you got to multiply the left side and the right side by 9. So I get 9y on the left. Let's do the side work here. 5/9 x times 9. Notice that these cancel, giving you 5x. Notice no more fractions. So when you distribute, you get 5x minus 9 times 4, or 36. One step away, you just subtract 5x, or add the opposite if you will. So negative 5x plus the 9y, because that's positive, right? I said add the opposite to both sides, is equal to negative 36. Okay? All right, number 8. Now you want to go back to section 5.5 again. So take out your section 5.5 notes out again, all right, to help you. In fact, you know, if you're smart, whenever you're doing a review, always have your chapter notes organized in order. Organize your chapter notes in order and use them. Okay, so important thing. Okay, so on this one here, A, when x equals 1, you want 2 points that determine a line. So 1, 2, 1, 4. So notice that I said x equals 1. So choose any two order pairs where the x coordinate's 1. How about 1, 2, 1, 4? So right, 1, 2 is here, 1, 4 is here. And so that line is a vertical line passing through 1. And we want to label as we go. So this is x equals 1. Now y equals 2. So when y equals 2, you want 2 points where the y coordinate is 2. So how about 1, 2 and negative 1, 2? So 1, 2 is here. Negative 1, 2 is here. So that is a horizontal line passing through. Oh, shoot, what did I do 2? I didn't mean that. I should be y equals 3. So what I said was correct for y equals 2. I'm going to go ahead and, no, I don't want to graph it. I had to just fix it. So instead of y equals 2, let's do y equals 3. Sorry, I was going too fast. So if y equals 3, then 1, 3 and negative 1, 3. So 1, 3 is here, negative 1, 3 is here. So it's a a horizontal line passing through 3 on the y-axis. Y equals 3. It's horizontal. Notice that I'm just choosing 2 points to determine the line. On the next one here, we have a slope of 1/3 and y-intercept of negative 1. So up 1/3, so up 1, right 3, up 1, right 3. Reverse it, down 1, left 3, down 1, left 3. And then draw your line. Okay, and then label. So this is y equals 1/3 x minus 1. Okay, and here we have, let me get 2 points here. Negative 4, 0, negative 4, 1. So negative 4, 0 is here. Negative 4, 1 is here. So it's a vertical line passing through negative 4. So this is x equals negative 4. And this last one here, the slope's negative 1. Okay, and what that means, it means down 1, right 1 from the y-intercept to negative 4. So down 1, right 1. Reverse it. Let's go the opposite direction. So go up 1, left 1, up 1, left 1. Always plot a bunch of points, you know, so it helps you see the line form. So this one here is y equals negative x minus 4. And y equals x plus 0. So slope's 1, y-intercept is 0. So remember, 1 is the same thing as 1 over 1. So y-intercept of 0 is here. Up 1, right 1. Okay, so that's y equals x right there. And notice how I'm labeling my lines. Okay, label your lines, people. Okay, when you have multiple lines on the same plane, you got to label everything. Okay, now let's classify. Okay, are the lines parallel, perpendicular, or are they neither? All right, and this is a slope question, so you got to analyze the slopes. Analyze the slopes. Let's go back to section 5.6. This is section 5.6 now. Okay. So in section 5.6, we're talking about parallel and perpendicular lines here. If you go back into the beginning here, look at this. Lines that are parallel are lines are parallel if and only if they have equal slopes. Lines are perpendicular if and only if their slopes are opposite reciprocals. So you need to go back to section 5.6 in order to be able to understand this question. Okay, so we need to analyze the slope. So we got to express in slope-intercept form first and analyze the slope. So I'm going to do that. I'm going to solve for y. So I get -5/4 x plus 3. So notice that the slope is -5/4. Here I'm going to add 4x to both sides. And I get 5y is equal to 4x minus 40. And then I divide by 5. So I get y equals 4/5 x minus 8. So the slope is 4/5. So if you compare this with this, notice that they're opposite reciprocals. So opposite reciprocals, that tells me that they're perpendicular. Perpendicular lines, okay? All right, that's how you do it. You analyze the slopes and then just look at them, okay? One more time. Let's let's isolate y here, and you get -3y equals -2x plus 6. Divide by -3. You get y is equal to 2/3 x. All right, minus 2. So the slope's 2/3. And notice right here, if we add 2/3 x on both sides, you get y is equal to 2/3 x plus 5. And notice that the slope is also 2/3. So if you compare this one with this one here, you'll notice that the slopes are equal. That tells me that the lines are parallel. All right, this goes back to section 5.6 on parallel and perpendicular lines. Just read the basic key ideas in each lesson and you'll get it. This is also section 5.6. Okay, so we want parallel. We want parallel to this line. So parallel means same slope. So I look here, and the slope's -3. So I'm going to use the slope of -3, and then I'm going to use the point 3, 0. So I always write down point slope form first. So I have y minus 0 is equal to -3 times x minus 3. Y minus 0 is just 0. Distributing 3, you get -3x plus 9. All right, and if you wanted to graph them to check, you can. The slope here is y-intercept's 1 and the slope's -3. So down 3, left 1. And if you graph that, let's see here. Looks like this. And then the other one has a y-intercept of 9, so you got to go up 9. 5, 6, 7, 8, 9. So it's way up here. It's off the grid. And then you go down 3, right 1. So if you're going to graph that one, you have to estimate. It's right about there. So they're parallel, but the other one, the second one, intersects up at 9. So it's off the grid. No big deal. And then this one here, you get 1/4 x minus 1. Hang on for a second. You know what? I'm wondering if I changed it for you guys. Okay, I noticed I changed the previous one on number 10 too. Shoot. Okay, so let's do this. Okay, let me start over because I change this in yours. I changed it to y equals 2x plus 1 through the same point, through a different point, 4 comma 0. So instead of using slope of -3, let's use the slope of 2. So the slope of 2. So let me recalculate. So y minus 0 equals 2 times x minus 4. You get y equals 2x minus 8. There we go. All right, now on this one here, I changed this one too. So y is equal to 1/5 x minus 1. And then this, a different point, -1 comma 0. So here on this one, be careful here because it says perpendicular. So I have to use the opposite reciprocal slope. Use opposite reciprocal slope. So I'm not going to use 1/5. I'm going to use a slope of -5, okay, because it's the opposite reciprocal. So y minus 0 equals -5 times x minus a -1. Simplify, I get y equals -5 times x plus 1. Then distribute, I get y is equal to -5x minus 5. I'm going to graph this one here. So graphing the first equation, so y-intercept's -1. The slope is 1/5. So there's my line right there. Okay, and the next one, slope is -5 starting at -5. So starting down here, so -5 is down 5 right 1. I'm going to reverse that. I'm going to go 5 divided by -1. So up 5 left 1. So up 5 left 1, up 5 left 1. And so I reverse the slope, and notice that it's up here. And guess what? These lines are perpendicular. They form a 90-degree angle between them. Okay? So you could see how the graph verifies my work right here. This result makes sense because they are perpendicular, which means they form a 90-degree angle between the two lines. All right, my friends. That was a little fast, but hey, it's a video, right? And it's a good resource. So if you need to, go ahead and rewind it and listen to any portion again. This is Mr. Ainsworth. I'll see you in my next lesson. Bye-bye now.